So we are on, this is just a continuation, and I put this up here just so I could write that in there. Isn't that nice? Alright, oops. My only problem is, say I hit the V, because that's my shortcut to go to the pen, but if I'm in the writing thing, it makes a V. Alright, here we go. You guys ready? We are going to change, we've talked about radians, haven't we? We've mentioned it from time to time, and you probably have no idea what a radian is. Would you agree with that? Alright, so what I've done here, I guess I could have started with this thing, but let me just go to this. I made this up for you, right, Danny? We listening now? We've started. Let's do this one right here. Oh, look at that. That's pretty slick, isn't it? Alright, so we've talked about radian. We're going to talk about radians, and this is what a radian basically is. This is basically the definition of what a radian is, and then I'm going to show you how to convert from degrees to radians. Radians really is just another way to measure degree is all it is. Alright, or a degree, an angle I should say. Okay, so radians is just another way, a different way to measure an angle. Now, of course, what do we measure angles with right now? What's the units that we use? Degrees, obviously. Okay, and you've been using those ever since you talked about an angle. So now we're going to talk about a thing called a radian. Now, what is a radian? Now, look what I've done right here. I said that this angle right here is equal to 1 radian. Well, maybe that might not be exactly technically right, but this is what it means. It means this. If I take a radius from here to here, this works with any circle, okay? If I take the radius, now, this is kind of hard to draw. I've actually practiced drawing this, but I'm not very good at it. If I took this radius, let's say it was a piece of string, right, and I wrapped it, and I actually have a little cardboard circle thing that I usually use as a demonstration, but that doesn't show up too well on this, so unless I put the camera on. If I wrapped it, I'm not going to do this all day because that's even worse. Alright, I'll go a little slower. My hand's not all that steady. Oh, getting there. Come on. And right there. Oh, that's not bad at all. Alright, see that line right there that I just drew? It's the same distance as this radius. You follow me? Alright, so all I did was take this radius and I went around like that. Now, how did I know that's 1 radius? Well, because when I first made this thing up, I figured out what that is in degrees, and I made this thing exactly the way it should be. But, alright, just trust me. If this was a piece of string, and I took it and I wrapped around the circle, that's 1 radius. You follow me? Okay, so it's the distance around the circle, around the arc of the circle, that equals 1 radius. Now, watch this. If I wrapped it once, I'm not going to draw that again, but you get the idea. If I wrapped it again, that's 2 radii, right? Basically, I should say this. This angle now is called 1 radian. You follow me? So this is 1 radian. This would be how many? 2 radian. This would be 3 radians, and this is a little tiny bit. Well, what number are you familiar with that is 3 and a little tiny bit? Pi, right? 3 what? 0.14, right, okay? So watch. If this right here is, let's go to another color. Let's just stick with red. Right? If this right here is 0 degrees, it would also be 0 radians because we haven't even started wrapping it around the circle yet. Would you agree with that? So that would be 0 radians. I'll just put RAD for a shortcut. Now right up here would be how many? What? This would be 1 radian. Now we're talking about the angle, right? I'm talking about from here to here. That's what I'm talking about. So if I go all the way to here, this would be what? 2 radian, or radians, I guess. And this right here, this point right here would be 3 radians. Now, if you go to here, which is how many degrees? 180 degrees. Then this is just a little bit, and we said it's that 0.14. So right here at this point, at 180 degrees, what would that be in radians? Pi radians, right. We're not going to say 3.14, we'll say pi radians. So that's exactly how we're going to write that. We're going to write pi radians. Okay with that? And that's why it is. There's other reasons you could show that, but I think that's a good example, a good way to show it. So 1 radian, 2 radian, 3 radian, and a little bit more is the 0.14 of a radian, right? 0.14 of this distance. You follow me? So if I actually measure this distance right here, multiplied it by 0.14, that would be this little tiny bit right here. All right? So that's pi radians. Let's keep going around. What if we went all the way around to here? It's 0 radians before we start going around the circle. Now, once we go around this circle like this, what is the angle? Now, in degrees, what would it be if you went all the way around the circle one time? It'd be 360 degrees. Now, in radians, though, if you go all the way around the circle, what is it in radians? Well, give me in terms of this. We didn't say 3.14. It's 2 pi, right? It's 2 pi. It's 2 pi radians. So 360 degrees is the same thing as 2 pi. Or you could say pi is the same thing as how many degrees? 180 degrees. So what we're going to do is we're going to use that as a conversion tool. We're going to say pi radians equals 180 degrees. Now that's what we're going to use when we do these conversions. Whoops. I forgot to change this. Okay, let's try this again. Because it filled it with white paper, that's why I covered it up. All right, so that's pi is equal to 180 degrees. Now what we can do is we can do some conversions with this. So let's do some ones that shouldn't be hard to figure out. We could probably figure this out in our head. So let's make a line straight up here. It's perpendicular. It's 90 degrees. All right. What is it in radians, though? That's what we want to figure it out. Now you should be able to just look at it. If from here to here is 1 pi radian, then from here to here would be how many? Be half a pi, wouldn't it? Would you agree? So we don't write half a pi, though. We write pi, what do you think? Over 2. So that's pi over 2 radians. All right. We're going to, in Algebra 2, we kind of do both. We use degrees and radians. Probably degrees maybe a little bit more than we use radians, but we're definitely going to talk about radians because I've talked to both teachers. I've talked to Mrs. Bonsbach for pre-calc, and I've talked to Mr. Jackson for calculus, and some of the kids that are in calculus. And they said, especially in calc, they use radians almost exclusively. They hardly ever use degrees, all right? So they use radians quite a bit. So this is good preparation for you when you get to that, all right? So that's pi radians. Let's go from here and straight down. Now, how many degrees would that be? 270 degrees. But in radians, what do you think? This is half a pi. This is 1 pi. This would be 1.5 pi, or as Papa say it? 3 pi over 2. Right, 3 halves, right? Because 1.5 is 3 halves. Would you agree? You know that, right? So 1.5 is the same as 2 times 1 is 2 plus 1 is 3 over 2. So it'd be 3 halves pi, or the way we simplify it, we usually say 3 pi, over 2. Okay? These are really key numbers, and these are numbers that you need to get in your head and really understand. So that's 3 pi over 2. Let's just do a conversion and see just another way why you think this would be pi over 2. For instance, we know that pi is equal to 180. So let's do a conversion with this right here. We said this was 90 degrees, didn't we? So what if they give you, and they're going to give you some problems like this. They're going to say, okay, here's an angle, and you want to convert that into radians. And they're going to do the other way. They're going to give you angles in radians, and you're going to convert it to degrees. All right, we're going to do it both ways. So what I'm going to do, I don't know if you've ever been shown this way of converting, but this is how I do it. I watch Khan Academy on this. He does it a little different way, and I think it's actually a little more confusing. Okay, so I like this way. I'm going to use this thing right here, pi and 180. Now, pi and 180 are exactly the same thing. Now, when I multiply, now if I made a fraction of something over itself, what is that? Say it, Lee. 1. It's 1, right. So anything over itself. So if I put pi over 180, they're the same thing, aren't they? Because we said they're equal to each other. What's something over itself? It's just equal to 1. Would you agree? Or you could write it the other way. You could go 180 over pi is also equal to 1. We're going to use these. These are conversion factors. The book I used to teach out of at my other school used another word, and I can't think of it off the top of my head. But anyway, that's basically what that is, a conversion factor. What we're going to do is we're going to come over here and multiply it by one of these, either this one or this one. All right? Now, how do we know which one to do? Because what am I trying to get rid of? I'm trying to get rid of, talk to me, degrees, and change it to radians. Okay? So that means if I have degrees on top, where does degrees have to be on this fraction? On the bottom, so they cancel out. So which one of these am I going to use? The first one, pi over 180. All right, so watch. This is how I like to look at it. I like to put this first because I'm trying to get rid of degrees. If it's on top, I put the degrees on the bottom. It's pretty simple to remember, I think. And then what's on top then? The pi. You with me? So watch what happens. This cancels. That goes once. This goes twice. Look what it is. It's pi over 2, just like we said it should be, didn't we? All right. Alright, let's pause this. We'll go to the next one.